What's up, math brainiacs? Welcome back to Arithmophilia. Don't forget to subscribe. For today's video, we are going to talk about the sum of infinite geometric sequence. But before that, let us be guided of our objectives for today. The following are the objectives that we need to achieve at the end of this video tutorial. First, determine the sum of the infinite geometric sequence, and second, solve real-life problem involving infinite geometric sequence. Without further ado, let's now start our discussion, starting with the definition and formula to be used for sum of infinite geometric sequence. The sum of the terms of an infinite geometric sequence, a sub 1, a sub 1r, a sub r squared, and so on, where r is less than 1 but greater than -1. It is given by the formula, s is equal to a sub 1, over 1 minus r, where a sub 1 is the first term and r is the common ratio. This formula is also known as the sum to infinity. This time, for us to better understand this concept, let's consider these following examples. Example number 1, find the sum of the infinite geometric sequence given that a sub 1 is equal to 16, r equals -1/2, and n which is 7. In solving this problem, the first two things we need to do are to identify the given values and substitute them to the formula. Mentioned above are the given values. So, let's now substitute them. We now have, s is equal to 16 over 1 minus -1/2. Next, we are now ready to solve for the sum to infinity of the given sequence. We will first transform the first equation into s equals 16 over 1 plus 1/2. Since, in the first equation, the operation in the denominator is being followed by a negative number, then negative times negative is equal to positive. Simplifying this equation, we can get s equals 16 divided by 3/2. Next, we will multiply 16 by the reciprocal of 3 over 2, and that is 2 over 3. We will perform direct multiplication in these two fractions. 16 times 2 is equal to 32. 1 times 3 is equal to 3. This gives us the final answer of 32 over 3 or 10 2/3. Therefore, the sum of the given infinite geometric sequence is 10 2/3. Are all these clear, brainiacs? Let's now proceed to our second example. What is the sum of the infinite geometric sequence 1/2, 1/4, 1/8, 1/16? Let us now perform the steps we have learned a while ago to solve this one. First thing we are going to do is, to identify the given and missing values. We have a sub 1 which is equal to 1/2 and the common ratio of 1/2. In getting the common ratio, we used 1/4 divided by 1/2. Here, we will just multiply the numerator by the reciprocal of the denominator, that is, 1/4 times 2 over 1. This gives us the product of 2 over 4, which still can be reduced into 1/2. Moving on to our final step, we will now substitute the given values and start solving for the sum to infinity. Using the given values, we obtain the equation, s equals 1/2, over 1 minus 1/2. Simplifying this, we get s equals 1/2 over 1/2, since 1 minus 1/2 is equal to 1/2. Next, to divide both fractions, we will again multiply the numerator by the reciprocal of the denominator. That is, s equals 1/2 times 2 over 1. Finally, this gives us the final answer of 2 over 2 or 1. Therefore, the sum of the given infinite geometric sequence is 1. Did you get it, class? If yes, let us now proceed to our activity. For you to practice your newly learned skill on determining the sum of infinite geometric sequence, try to do this task on your own in your notebook. Perform the activity entitled, Something to Do, by finding the sum to infinity for each geometric sequences. Good luck, brainiacs. This time, let's us try to reflect on this question. How can knowledge on sum of infinite geometric sequence will help us analyze and solve real-life problems and make our decisions? Let's go and see. Navi Grace drops a rubber ball off of a building that is 64 feet high. Each time it strikes the ground, it bounces back to 3/4 or 75% of its previous height. If the ball continues to follow this pattern, what will be the total vertical distance it travels? The first thing we need to do is to sketch the scenario and plug in all the needed information. We have a rubber ball, and it is dropped from a height of 64 feet and it rebounded 2/3 of its previous height, then continues. Looking into the vertical distances traveled by the ball, it formed a geometric sequence, with the first term of 64, followed by 48, 36, 27, 20.5, and so on. Common ratio of 3 over 4. If you have noticed as well, the motion of the ball consists of downward movement, combined with upward movement. In order for us to get the total vertical distance traveled by the ball, we need to solve for the total downward and upward motion of the ball and add their results. Using the concept of sum of infinite geometric sequence, let us now start solving for the total downward motion of the rubber ball. Considering that our first term is 64, and common ratio of 3/4, let us now substitute this to our formula, S sub d, which stands for the sum of distance of the downward motion, equals a sub 1, over 1 minus r. We have now, S sub d, equals 64 over 1 minus 3/4. Simplifying this, we get, S sub d equals 64 over the difference of 1 and 3/4, which is 1/4. Next, we will multiply 64 by the reciprocal of our denominator. We have now, S sub d equals quantity 64 over 1, times quantity 4 over 1. This gives us the product of 256. Therefore, the sum of the distance of downward motion is 256 feet. Are all these clear? If yes, let us proceed to the upward motion. Now, we are going to let solve for the total upward motion of the rubber ball. This time, our first term is 48 feet, and common ratio of 3/4. Let us now substitute this to our formula, S sub u, which stands for the sum of distance of the upward motion, equals a sub 1, over 1 minus r. We have now, S sub u, equals 48 over 1 minus 3/4. Simplifying this, we get, S sub u equals 48 over the difference of 1 and 3/4, which is 1/4. Next, we will multiply 48 by the reciprocal of our denominator. We have now, S sub u equals quantity 48 over 1, times quantity 4 over 1. This gives us the product of 192. Therefore, the sum of the distance of upward motion is 192 feet. To answer the question, what is the total vertical distance traveled by the rubber ball, we will add the results of S sub d, and S sub u. That is, 256 feet plus 192 feet equals 448 feet. I hope that you have understood all the steps we have discussed today. Good job, Brainiacs! Before ending this lesson, please take note of this. For you to measure your previously learned understanding on sum of infinite geometric sequence, you can answer the 10-item test that I have prepared for you on my quizzes.com account. How? Just search or click the link in the video description below. Enjoy! This ends our lesson for today. Thank you, Brainiacs. See you on our next episode.